Okay, we're moving on to section 3. So section 3 says that we're finding the inverse of a square matrix. And you can only find the inverses of square matrices, so that's kind of a... So we could just say the inverse of a matrix. It implies that it has to be square. And the key thing about inverses is if you take a matrix and its inverse, the resulting matrix is what is called the identity matrix. And for a 2 by 2 matrix, the identity matrix, which we use the symbol I for, is 1, 0, 0, 1. And the key thing about an identity matrix is if you take a matrix and you multiply it by the identity matrix, you have the original matrix. Now the dimensions of the identity matrix have to be such that the second dimension of A is this first dimension is the size of the matrix. So it's kind of like in algebra, A is equal to 1 times A. So the equivalent in matrices is the identity matrix. Instead of multiplying by 1, we multiply by the identity matrix. Now, another reason inverses are important is you can solve, it's another way of solving linear equations. In chapter 1, or section 1, we looked at solving systems of linear equations using the row echelon and the reduced row echelon or Gaussian elimination method. And this is just another way of solving equations. So that's the background here. So when it says in problem number 1, show that B is the inverse of A, that means what we should expect is A times B equals I. So they're written down here, so let's just do the multiplication. And what I'm going to do is I'm going to make a big matrix here and show the multiplication. So this entry, the first row, first column, is going to be 1 times 3/5 plus -1 times 1/5. Actually, I did that wrong. So we can take this times that plus this times that, so it's -1 times -2/5. I knew to do something wrong because it didn't work out. Okay, so that's the first entry of the resulting matrix, which we're trying to show is the identity matrix. Okay, the second one, first row, second column. First row, second column, so that's here, is going to be equal to 1 times 1/5 plus -1 times 1/5. So that's this times that plus that times that. Then we go down here, second row, first column. Second row, first column. We have 2 times 3/5, 2 times 3/5 plus 3 times -2/5. So that gives us this part of the resultant matrix. And then we have 2 times 1/5 plus 2 times 1/5 plus 3 times 1/5. So it's 2 times 1/5 plus 3 times 1/5. Close the matrix out. So here we have 3/5, and then we have -1 times minus times a minus is plus. So it's 3/5 plus 2/5, which is 5/5, which is 1. Here we have 1/5 minus 1/5, which is 0. Here we have 6/5 minus 6/5, which is 0. And here we have 2/5 plus 3/5, which is 1. So that's how you show that these are inverses of each other. So that's a 2 by 2 matrix. 3 by 3 matrix, here they are. So it's probably best to put these right next to each other. It'll be easier to keep track of everything. Okay, so we're going to take that, we're going to multiply by its inverse, and we should end up with the identity matrix, which, the identity matrix has zeros everywhere except ones along the diagonal. And again, they have to be square matrices, which means that the dimensions, the row number of rows equals the number of columns. Okay, so here's our resulting matrix, which is 3 by 3. So we're going to have 2 times 1, negative 17 times 4. So I'm just going to write these out. Negative 17 times 4, that's negative 68. And then 11 times, did I do this right? This times that. Yeah, negative 17. Yeah, I did that wrong. Okay, so take this row times that column. So you get negative 34. So negative 17 times 2 is negative 34, and 11 times 3 is plus 33. And you can see when you add that together, we'll end up getting 1. Okay, the next, so that's the first row, first column. Second row, first row, second column, you have 2 times 1, and you have 17 times 4, which is 68, so that's minus 68. And then 11 times 6, which is plus 66. You can see that's going to go to 0. Then you do first row, third column, so you're going to have 4. 2 times 2 is 4. You got plus 51. And then 11 times 5 is minus 55. You see that's going to go to 0. Okay, then we do second row, first column. Second row, first column. So you're going to have negative 1 times 1, which is negative 1. 11 times 2, which is 22. 22. And negative 7 times 3, which is negative 21. You see that goes to 0. Then you do the second row, second column. So you'll get negative 1 plus 44 minus 42. So it's this times that, plus that times that, plus that times that. Okay, then you have third row, second row, third column. Second row, third column. So you end up with negative 2 minus 33 plus 35. That'll go to 0. Then you have this row and this column, so you're going to have 0. 0 times 1 is 0. This is 6 minus 6. Okay. This times that, 0, 6, negative 6. Then you have 0 times 1, which is 0. 3 times 4, which is 12. 6 times, negative 2 times 6 is negative 12. And finally, third row, third column. 0 times 2 is 0. Negative 3 times 9 is negative 9. And negative 2 times negative 5 is plus 10. So here, 35 minus 34 is 1. Negative 68 plus 68 is 0. This goes to 0. This goes to 0. This goes to 1. This goes to 0. This goes to 0. This goes to 0. This goes to 1. So what we end up with is the identity matrix, meaning 1's along the diagonal, 0's everywhere else. So that proves that these are inverses of each other. Okay, now, so how do we, now that we know how to prove two matrices are inverses of each other, how do we find the inverse of the matrix? Well, there's two ways. There's a formula, and there's using the this row echelon form. So I think I'm going to use the row echelon form. So what you do is you take the original matrix and augment it with a identity matrix. that. And what you want to do is do row operations so you end up with 1 0 0 1 here, and then the result over here will be the inverse. So we need a 1 here, so that's great. We're in good shape. The next thing we're going to do is we're going to take row 2 and we're going to subtract 3 times row 1. Why? Because I want 3. If I multiply this by 3 and subtract it from 3, I'll get 0. So this is going to, row 1 stays the same for right now. So let's take 3 times row 1. So that's row 1 here. So you get 3, 6, 3, 0. And so what we're going to do is take row 2, subtract row 3 times row 1. So you see I get 0. 3 minus 3 is 0. 7 minus 6 is 1. 0 minus 3 is minus 3. And 0 minus 1 minus 0 is 1. So I've got 0 here now. It turned out I got 1 here, so that's great. Just making life easy for us. So the next thing we're going to do is we're going to leave the last row the same because it's exactly what we're looking for. And we want to get a 0 here. So what we're going to do is we're going to keep row this new row 2. This is new row 1. So we're going to keep row 2 the same, and we're going to take row 1 and we're going to subtract 2 times row 2. That's so when I subtract 2 times this from that, I get 0. So let's go ahead and write out what I need is 2 times row 2 here. So here's row 2. 2 times 0 is 0. 2 times 1 is 2. 2 times negative 3 is negative 6. And 2 times 1 is 2. And then we're going to take row 1 and we're going to subtract 2 row 2, and we're going to put it right there. So we just take 1 minus this is 1. 2 minus 2 is 0. 6 minus this negative 6 is 6 plus 6, which is 7. And 0 minus 2 is negative 2. And so what that says is that the inverse of this matrix is going to be 7, negative 2, negative 3, 1. And we can check that out by taking this inverse matrix and multiplying it by the original matrix, and hopefully we get the inverse matrix. So the result is a 2 by 2. So you take 7 times 1 plus 2 times negative 3, so that's 7 minus 6, which is 1. This is going to be the second row, second column, first row, second column. So we get 1 times negative 2 and 2 times positive 1. So that goes to 0. Minus 2 plus 2. Here we get 21 minus 21, so 0, plus 21 minus 21. And then we get negative 6 plus 7 is 1. So check. Okay, do the same thing on the next one. So we start with our matrix. We augment it with the identity matrix. First thing we want to do is get a 1 here. So the easiest thing to do would be to switch the rows. So we switch all the rows. So this one switches there, and this one switches there. Okay, now we're going to take row 2 and we're going to subtract 2 times row 1. So again, this is row 1, this is row 2. We're going to leave row 1 the same because it has a 1 right there, so it's perfect. So let's write out. We need 2 times row 1, 2R1. So we just doubled these numbers, 2, 8, 0, 2. So we're going to take row 2, subtract 2 times row 1, put our answer right there. 2 minus 2 is 0. 3 minus 8 is negative 5. 1 minus 0 is 1. 0 minus 2 is negative 2. Okay. Now we need that to be a 1. So we're going to leave row 1 the same. So we're going to take row 2 and divide by negative 5. So 0 divided by negative 5 is 0. Negative 5 divided by negative 5 is 1. 1 divided by negative 5 is negative 1/5. And negative 2 divided by negative 5 is positive 2/5. Okay? And now we need this to be 0. So what we'll do is we'll leave row 2 the same, and we'll take row 1 and we're going to subtract 4 times row 2. So take this times 4 and then subtract it. So we need 4R2. So multiply this by 4, so you get 0, 4, minus 4/5 plus 8/5. So that's 4 times row 2. What I'm going to do is take row 1, subtract 4 times row 2. 1 minus 0 is 1. 4 minus 4 is 0. 0 minus 4/5 is plus 4/5. And 1 minus 8/5, well, this is 5/5. So 5/5 minus 8/5 is negative 3/5. So my inverse matrix is 4/5 minus 3/5 minus 1/5, 2/5. So that's my inverse matrix. And I can check my results here by multiplying by my original matrix and see if I end up with the identity matrix. So I've got 2 times 4, so that's 8/5. And I've got 3 times negative 1/5, so that's minus 3/5. Then for this one I take first row times second column. So I've got 2 times negative 3, so that's negative 6/5. And then I have 3 times 2, which is positive 6/5. For here I take the first row times the first column. So I've got 4/5. 1 times 4/5 is 4/5, and 4 times negative 1/5 is negative 4/5. And then I have negative 12/5. So 3 times 4 is 12. And then I have, did I do that right? No, I'm doing the wrong ones here. Let's try it again. This row times that column. So you've got negative 3/5 plus 8/5. Is that right? 3/5, negative 3/5 plus 8/5. Okay. So 8 minus 3 is 5. So you get 5/5. Here you get 0. Here you get 0. Here you get 5/5. This is 3. 8 minus 3 is 5/5. And 5/5, of course, is 1. So you get 1, 0, 0, 1. So that worked. Okay, the next one's going to be more difficult because it's a 3 by 3. But just have to be strong here. Okay. We already have 1s in the first row, so that's nice. We're not do anything. We have 1 in the first row, first column, so that's good. Then the next matrix is we're going, oh, and we got to augment that. I almost forgot. There. So we augment that with the 3 by 3 identity matrix. Like that. So I need to make this thing wider. So we got 1, 1, 1, 1, 0, 0. So what we'll do is we'll take row 2 and we'll subtract 3 row 1, and we'll take row 3 and subtract 3 row 1. Why? Because I've got 3 right here. So we take 3 row 1. We're leaving row 1 the same, but we're going to multiply by 3. So take each one of these. So it's just going to be 3, 3, 3, 3, 0, 0. So we're going to take row 2, subtract 3 times row 1. So this minus that gives you 0. 5 minus 3 is 2. 4 minus 3 is 1. 0 minus 3 is negative 3. 1 minus 0 is 1. 0 minus 0 is 0. Okay. Then we take this and subtract this. 3 minus 3 is 0. 6 minus 3 is 3. 5 minus 3 is 2. 0 minus 3 is negative 3. 0 minus 0 is 0. 1 minus 0 is 1. Okay. Next thing we need to do is get a 1 here. So what we'll do is we will just take row 2 and divide by 2. So we divide everything by 2, so you get a half, negative 3 halves, 1 half, 0. And we'll leave row 3 the same for right now. Okay. Now, I want to get this to be 0. So what I'll do is I will take row 3 and subtract 3 times row 2. So let's go ahead and fill in rows 1 and 2, which are not going to change for this step. Okay, and let's write in 3 times R2. So that's going to be 0, 3, 3 halves, minus 9 halves, 3 halves, 0. So I'm taking this, multiplying everyone by 3. And then I'm going to take row 3 and I'm going to subtract 3 times row 2. So 0 minus 0 is 0. 3 minus 3 is 0. 2 minus 3 halves is 1 half. Negative 3 minus a negative 9 halves, that's so that's 6, negative 6 plus 9, that's plus 3 halves, because we got 6 halves, negative 6 halves, plus 9 halves, so that's 3 halves. Okay, then we have this plus that, which is 3 halves. Actually, this minus that, so it's a minus sign. Make sure I'm doing this right here. This minus that, this minus that, this minus that, and this minus that. So that becomes 1. Okay, now we want this to be 1. So all we have to do is multiply row 3 by 2. So we're going to take row 3, multiply by 2. 1, 1, 1, 1, 0, 0, 0, 1, 1 half, negative 3 halves, 1 half, 0, 0, 0, 1, 3, negative 3, 2. So I just multiplied everything here by 2. Okay, now we need to make these two zeros. So we're going to leave row 3 the same. That's what we're basing this all on. Because we have 0, 0, 1. What we need is 0, 1, 0 and 1, 0, 0. So this is row 3. And what we're going to do is we're going to take, here we're going to take row 2 and subtract 1/2 row 3. So that I can get it, this will be a half. So let's do 1/2 row 3. So here's row 3. Same thing. So we're going to multiply everything by a half. So you get 0, 0, 1/2, 3/2, minus 3/2, 1. And we're going to subtract this from that. R2 minus 1/2 times R3. So you'll get 0, 0 minus 0 is 0. 1 minus 0 is 1. 1/2 minus 1/2 is 0. Minus 3/2 minus 3/2, so that'll be minus 6/2, so that's minus 3. And then we have 1/2 minus 1/2 minus a minus 3/2, so that's 1/2 plus 3/2, which is 4/2, which is 2. And then we have 0 minus 1, so we get negative 1 there. And then we're going to do the same kind of thing here. Well, yeah, all we have to do here is take row 1 and subtract row 3, because if I subtract this from that, I'll get 0. So I'm just going to, let me just dot it. So we're going to take row 1, subtract row 3. Row 1 minus row 3. So you get this minus that, which is 1. This minus that, which is 1. This minus that, which is 0. That minus that, which is negative 2. This minus that, which is 3 plus 0 plus 3, so that's 3, and 0 minus 2 is minus 2. Okay. So that is where we are, and the only thing we need to do is get a 0 there, so you can see I can just subtract my final operation here. Is I'm going to leave row 3 the same, leave row 2 the same, and take row 1 and subtract row 2. So I'm going to take, let me use a color here, green, so I'm going to take row 1 and subtract row 2. This minus that. So you have 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 0 is 0. 2 minus a negative 3, that's 2, negative 2 plus 3, which is 1. 3 minus 2, which is going to be positive 1. And negative 2 minus a negative 1, which is negative 2 plus 1, which is going to be negative 1. So what it's saying is that the inverse matrix to this is going to be 1, 1, negative 1, negative 3, 2, negative 1, 3, negative 3, 2. And if we multiply that by the original matrix, which is 1, 1, 1, 3, 5, 4, 3, 6, 5. So if we multiply these together, we'll get a 3 by 3 matrix. And I'm just going to show you how it goes. 1, so we take the first row times the first column. So we get 1 minus 3 is negative 2. Negative 2 plus 3 is 1. Then we do the first row, second column. We'll get 1 plus 2 is 3. Minus 3 is 0. Then we do the first row, third column. Negative 1 plus negative 1 is negative 2. Plus 2 is 0. Then we do the second row, first column. 3 minus 15 plus 12, that's 0. Then we do the second row, second column. 3 plus 10 is 13, minus 12 is 1. Then the second row, third column, negative 3 minus 5 is negative 8, plus 8 is 0. Then we do the third row, first column. 3 minus 18 is negative 15, plus 15 is 0. Third row, second column. 3 plus 12 is 15, minus 15 is 0. And finally, negative 3 minus 6 is negative 9. Negative 9 plus 10 is plus 1. So it does work out. So that was good. Okay, so let's do another 3 by 3 matrix. Find the inverse of that matrix. So again, what we do is we create this augmented matrix with the identity matrix. So that's our original matrix, and then the identity matrix is as such. So this is a 3 by 3. Matrices have to be square to be able to take the inverses of them. Okay, so that's my augmented matrix. So you can see row 1 is good because it has a 1 in the first spot. The next step is to make those go to 0. So let's write our matrix out here, and this is row 1, this is row 2, this is row 3. So what we're going to do is we're going to replace row 2 by taking row 2 and subtracting 3 times row 1. So that if we take 3 times this row and subtract it from row 2, then we're going to get 0. Now the first row is intact at this point. So let's write it out. So let's do 3 times row 1. 3 row 1. So then I can subtract it. So we take row 1 here, multiply it by 3. We get that. Now we're going to take row 2, subtract 3 times row 1. 3 minus 3 is 0. 7 minus 6 is 1. 9 minus 6 is 3. 0 minus 3 is negative 3. 1 minus 0 is 1. 0 minus 0 is 0. Okay, next thing. We're going to replace row 3 by row 3 plus row 1. Because here I have negative 1. If I add row 1 to row 3, then I'm going to get 0 in this. So that's what I'm trying to do. So we're going to take row 1, add it to row 3. I don't need to multiply it out here because I've already got everything I need. So 1 plus negative 1 is 0. 2 plus negative 4 is negative 2. 3 plus 7. 3 plus negative 7 is negative 5. 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 1 is 1. Okay. So now we got ones, zeros here. Now we need a 1 there. Well, that's very nice. So we've already got that part. So for the next step is all we're going to do is try to get a 0 here. So we can write row 1 and row 2 as they are. Now if this number here were something other than 1, we just divide the whole row by whatever that number is. Okay, so what I'm going to do is I'm going to replace row 3, and I'm going to add 2 times row 2 plus 2 times row 2. So let's do 2 times row 2 up here. So here's row 2. So I'll get 0, 2, 6, minus 6, 2, 0. So this row multiplied by 2. So we're going to take row 3. This is the new row 3. This is the new row 2. This is the old and new row 1. So we're going to take row 3 and add it to 2 times row 1. So you get 0 plus 0 is 0. Negative 2 plus 2 is 0. That's what we're trying to do. Negative 5 plus 6 is 1. 1 plus negative 6 is negative 5. 0 plus 2 is 2, and 1 plus 0 is 0. Now, not only did getting a 0 here work, but we also got a 1 there. So that would have been the next step. If this had been something other than 1, we would have divided that entire row by 1. They're just being nice to you here for this problem that I copied out of the book. Okay, so now what we're going to do is we're going to make these two go to 0. So we're going to go the other way. So we're going to start with row 3. That's exactly what I want. I get 0, 0, 1. What I need is 0, 1, 0 and 0, 1, 0, 0. So since we're going to do two things, I'm going to pull this down a little further so I have more room. Okay, and again, this is row 3, this is row 2, this is row 1. So we copied row 3 down, and what we're going to do is we're going to take row 2, and we're going back here. So we want this to be 0, so we're going to subtract 3 times row 3. What that'll do is if we subtract 3 times this, that number is going to go to 0. And because these are 0, they don't affect these two elements, which we already have where we want them to be. So let's do 3 times row 3. Here's row 3, same one's down there, so I'm just going to do it here because it's easier to find. 3 times this row. So we get 0, 0, 3, negative 15, 6, 0. Double check. Okay. So now what we're going to do, we're going to replace row 2 by taking row 2 and subtracting 3 times row 3. And we're going to put the results right there. So this minus that is 0. This minus that is 1. This minus that is 0. Negative 3 minus a negative 15. That's negative 3 plus 15, which is 12. Then we have 1 minus 6, which is negative 5. And 0 minus 0, which is 0. Okay, now we want to get this term to go to 0. So we're going to take row 1, and we're going to subtract 2 times row 3. So here's 2 times row 3. So we take row 3, multiply by 2 instead. Okay, so that's 2 times row 3. So we're going to take row 1, and we're going to subtract 2 times row 3. That's what row 1 minus 2 times row 3. And we're going to put the result there. So we're going to take this minus that. There's the minus sign. 1 minus 0 is 1. 2 minus 0 is 2. 2 minus 2 is 0. 2 minus 2 is 0. 1 minus a negative 10 is 1 plus 10, which is 11. 0 minus 4 is negative 4. 0 minus 0 is 0. So it's just seems like we had an error here. I think I made a mistake up here. The reason I've got this 0 here, and that bothers me. So let's go back and look at that. So what we said was we took row 2 and added 2 row. So we add, yeah, this should be 1. Let's see how that affects the next thing. So this has to be 1 right there. Okay, let's redo this one. So what we're going to do is take row 3 and subtract this. So that's 1 minus 0 is 1. Okay, so that's good. And then, wait a second. So this should be 1 as well. Because what we're doing is we're going to take this one and subtract. Oh, yeah, I got to fix this here. So this was 3 times row 3. So that instead of 0, that's 1. So that's going to be 3. And this one's going to be 4, or 2. That's 2 times row 3. So put that in there, 2. Okay, so to get this entry, we took this minus that, which is negative 3. And for this one, we take row 1 minus 2 times row 3, which is minus 2. Okay. Now I think we're okay. Now the final thing I need to do is to make this go to 0. So we're only going to need to have to do one operation. Rows 2 and 3 are finished. 0, 1, 0, 12, negative 5, negative 3, 0, 0, 1, negative 5, 2, 1. So what we're going to do is we're going to replace row 1 and we're going to subtract a multiple of row 2. So we're going to subtract 2 times row 2. So let's write down what row 2 is. So row 2 is this. This is row 2. So multiply everything here by 2. So you get 0, 2, 0, 24, minus 10, minus 6. And then we're going to take row 1, which is this one right here, and we're going to subtract 2 times row 2. 1 minus 0 is 1. 2 minus 2 is 0. 0 minus 0 is 0. 11 minus 24 is negative 13. Negative 4 minus a negative 10 is negative 4 plus 10, which is going to be 6. And we have negative 2 minus a negative 6, which is negative 2 plus 6, which is 4. So what it says is if this is, say, matrix A, then the inverse of matrix A is going to be negative 13, 6, 4, 12, negative 5, negative 3, negative 5, 2, 1. And we'll see if that works or not. So if we take matrix A and we multiply by its inverse, so we're not doing an augmented matrix here, we're actually multiplying them together. And you can multiply them together because this is a 3 by 3 and this is a 3 by 3, and because these two numbers are the same, works. You can always multiply square matrices together that have the same dimensions. Okay, so let's do this. So the top here, we're going to have negative 13 plus 24, which is going to be 11, 11 minus 10 is 1. Okay, first row, second column. We're going to take 1 times 6 plus 2 times negative 5, which is going to be 6 minus 10, which is negative 4. 2 times 2 is 4, so that just comes out to 0. First row, third column. Multiply the first row by the third column. So you've got 4 times plus negative 6, which is negative 2, plus 2 gives you 0. Now at this point, I feel pretty confident because, you know, for that to work out if I'd made an error is pretty unlikely. But we'll finish it off here. So you've got negative 39, 3 times negative 13, plus, I'm going to have to put this in my calculator because I can't do all that in my head. So what we'll do is 3 times negative 13 plus 7 times 12 plus 9 times negative 5. That should come out to be, oh, must have done something wrong here. Yeah, I did. I didn't fix my calculator. 0. So that comes out to be 0. Then I go multiply the second row times the second column, and that'll be 18 minus 35 plus 18. And that comes out, oops, forgot to use the negative extra thing in there. It comes out to be 1. So it is I multiplied this row times that column. Now I'm going to do this row times that column to get this. So there you have 3 times 4 plus 7 times negative 3 plus 9 times 1. So 3 times 4 minus 7 times negative 3 plus 9 times 1. That comes out to be 0. Then I have this entry, so I'm going to take the third row, first column. So you have this times that, plus that times that, plus that times that. So that'll be 13 minus 48 plus 35. That's 0. Then I do the third row, second column. So I'm going to have negative 6 plus 20 minus 14. That's 0. And then I do third row, third column. So I'm going to this times that, plus that times that, plus that times that. So you have negative 4 plus 12 minus 7. It's equal to 1. So there you go. Cha-ching. So that's the inverse. Okay. Now the last bit is going to be solving linear equations using the inverse. So what we're going to do is we're going to take the matrix, the A matrix, which is 3, 4, 5, 3, and find its inverse. So let's say this is matrix A. We want to find the inverse. Now, this one I'm going to use this formula that's in the book, which says it's 1 over A times D minus B times C times the matrix, and let me find it. And this works for 2 by 2 matrices. So you get D minus B and minus C A. Actually, we'll do them both ways. So this is A, B, C, D. So you get 1 over A times D, so that's 9, minus B times C, which is this way. So you get 9 minus 20. And then what you do is you switch. This is A and this is D, so you switch A and D, which they're both 3. So this B goes up there and that comes down to there. And then you A, B, C. So these you leave the same, but you change the sign. So this becomes negative 5, and this becomes negative 4. And if you carry out the math here, you'll get 1 over negative 11. This is what's called a scalar. It's just a multiplier, and you handle that by multiplying each term by this fraction. So you end up with negative 3/11 plus 4/11, because negative times the negative. Then you got negative 1/11 times negative 5, so that's positive 5/11, and then you get negative 3/11. So that's your inverse matrix. So let's do the same thing, but using the other approach. If I ask you to do it, I'll probably ask you to do it this way, but I just wanted to demonstrate there is another way of doing it for 2 by 2 matrices. Okay, so what we would do is, you can see that neither one of these are 1, so it doesn't help switching it out. So I'm just going to divide the first row by 3. Okay, so now I've got a 1 here, go down. I need to make that a 0. So what I'll do is I'll keep row 1 the same, and I'll take row 2 and I'll replace it with row 2 minus 5 times row 1, because I need 5 times this and then subtract it to get 0. So let's write out 5R1. So here's row 1, so you get 5 20/3, because you've got 4 times 5 is 20. 5 times 1 is 5, so you get 5/3, and you get 0. Okay, and then we take row 2 and we subtract row 5 times row 1. So 5 minus 5 is 0. 3 minus 20/3. Okay, so this is 9/3. 9/3 minus 20/3 is minus 11/3. 0 minus 5/3 is minus 5/3. And 1 minus 0 is 1. Okay, next. What you're going to do is, you want to get a 1 here. So all we're going to do is we're going to take row 2 and multiply by negative 3/11. Because if we multiply negative 11/3 by negative 3/11, it'll become 1, and that's the goal here. So 0 times this is 0. 0 times that 0. 0 times negative 3/11 times negative 11/3 is 1. Then we have negative 3 times, well, actually, you can see the 3's cancel out and the negatives cancel out. So if you take negative 3/11 times negative 5/3, you're going to end up with 5/11. And then 1 times negative 3/11 is negative 3/11. That first row remains the same from that. So first thing, divide the first row by something, by 3, to get a 1 here. Next step is to get zeros in this entire column, which in this case is just 2. So we took row 2 and subtracted 5 times row 1. Then we took row 2 and multiplied by the reciprocal of whatever is there to get a 1 there. Now the final thing is to get a 0 here. So row 2 is good. And what we're going to do is we're going to take row 1 and we're going to subtract. So we want to subtract 4/3 times row 2. Because if I do that, if I multiply this by 4/3, I'll get 4/3, and then I subtract it from 4/3 and I'll get 0. So what I need to do is write out 4/3 row 2 here, so I can do that. So here's row 2, so you'll have 0 times 4/3. You'll have 1 times 4/3. Here we'll have 20 over 33. And here we'll have 3 times 4 is 12, so we'll get negative 12 over 33. Okay, let me just move this thing down a little bit. So we're going to take row 1 and subtract 4/3 times row 2. So you get 1 minus 0 is 1. 4/3 minus 4/3 is 0. 1/3 minus this. So what I need is to convert this to 30/3. So that's 11 30/3. Take 1 times 11 is 11. 3 times 11 is 33. And here we just have 0. So we're going to take 11 30/3 minus 20 30/3. That's going to be minus 9 30/3. And here we have 0 minus 12 30/3. And you can simplify those down now. So we're not going to divide, and we're just going to simplify these fractions. So these are both divisible by 3, so that becomes negative 3 over 11. Both divide those by 3, and you do the same thing here. You divide both by 3, so you get 4 over 11, and you get 5 over 11, and negative 3 over 11. And we look over here and you have a negative, so that the resulting here says that the inverse matrix of A is negative 3/11, negative 4/11, 5/11, and negative 3/11, which is, I got a sign wrong here. What did I do? Oh, there's a sign error down here. I think, yeah, that should be, well, yeah. So that's where I went wrong here. So I took, this should be positive. Therefore, this should be positive, because if I took 0 minus a minus, so that's going to be positive. So that's positive 12 30/3, which is positive 4/11, which is positive. So now they match up. So that's the inverse. So now how do we solve this thing? So what you're going to do is you're going to multiply. You take the inverse of the matrix, negative 3/11, 4/11, 5/11, negative 3/11, and you're going to multiply that inverse by the B matrix, which is negative 2, 4. So what we'll have is, and we end up with a 2 by 1 matrix, because we have a 2 by 2 multiplied by a 2 by 1, hence the result should be a 2 by 1, the outside dimensions. So you're going to have, let me just make this bigger so I can show what we're doing. So we're going to take first row times the column. So you have negative 3/11 times negative 2 plus 4/11 times 4. And then this one's going to be the second row in the column. So you're going to have 5/11 times negative 2 plus negative 3/11 times 4. And so what do we have? We have 6/11 plus 16/11, so you get 22/11 from here, and here we'll have negative 10 minus 12, so we have negative 22/11. So that's the solution, but you can simplify those down to positive 2 and negative 2. So that's the solution matrix. So x equals 2, y equals negative 2. And if we go back and plug those in here, we'll have 3 times 2 plus 4 times negative 2. So that's 6 minus 8, which is negative 2. Check. And then we have 5 times 2 plus 3 times negative 2. So you get 10 minus 6, which is 4. Checks out. Okay, so that's number 7. So we're going to do the same thing for the next one. We'll do it both ways. The first thing you do is to rewrite this in matrix form. So it's 7, negative 3, 1, 4. And that's multiplied by x, y. And that equals 4, 12. Okay, so the first way of doing it is to say that the inverse matrix A minus, this is the A matrix, this is the X matrix, this is the B matrix. The inverse matrix, remember, is 1 over AD minus BC, and what we do is we have D minus B minus C. I'm looking in the book because I don't have this memorized. So let's see what we get. We get 1 over 27 times 4, which, I mean 7 times 4, which is 28. Subtract negative 3 times 1, so that's plus 3. And then you switch these two, so this becomes a 4, that becomes a 7, and then you leave those, but you change the sign, so this becomes negative 1, this becomes positive 3, and so here you get 1 over 31, so this is 4 over 31, 3 over 31, negative 1 over 31, and 7 over 31. Okay, so that's using the formula. Now the other way is to take the coefficient matrix and augment it with the identity matrix. And you can see the first step is I just switch row 1 into row 2. Okay. Now I have a 1 up here, so the next step is to make that a 0. So we're going to leave row 1 the same right now. And we're going to take row 2, and we're going to subtract 7 times row 1, because I need to get that to go to 0. So you take 7 times row 1. So here's row 1. So you get 7, 28, 0, 7. Okay, so we're going to take this row, row 2, subtract 7 times that. 7 minus 7 is 0. Negative 3 minus 28 is negative 31. 1 minus 0 is 1. 0 minus 7 is negative 7. Okay, next thing. We're going to leave row, well, we need to take row 2 and divide by negative 31. So row 1 stays the same, and divide by negative 31, that makes that go to 1. Then you get negative 1 over 31, and positive 7 over 31. final step is to make that 0. So we're going to leave row 2 the same. And you can already see that the second row here matches up, so that's encouraging. What we'll do is we'll take, so we're going to take row 1 and subtract 4 times row 2, because this is 1, this is 4, so I need to have 4 times. So let's write down 4 row 2. So that's 0, 4, negative 4 over 31, plus 28 over 31. And then we're going to replace row 1 with row 1 minus 4 times row 2. So 1 minus 0 is 1, 4 minus 4 is 0, 0 minus 431st is positive 431st, and 1 minus 28 31st. Well, this is 31 31st. So 31 minus 28 is 3. So we get 3 31st. And as a consequence, the inverse matrix is 4 31st, 3 31st, negative 1 31st, 7 31st. And you're done, and you got the same answer. Okay, so that's the inverse. Then what you can do is you can say that the solution is the inverse matrix times the B matrix. Okay, so again, it's going to be a 2 by 1, 2 rows by 1 column. I'm making it big here so I can show the multiplication. So you're going to have 4 31st times 12 plus 3 31st, pardon me, times 4. This times that, and that times that, so that's times 12. And then here the second row is negative 1 31st times 4 plus 7 31st times 12. So you'll have 4 times 4, which is 16, plus 3 times 12, so that's 36, plus 16, which is 48. Is that right? No, that's 36 plus 16. That's 50. What are we doing here? We're taking 16. 4 times 4 is 16. 3 times 12 is 36. So that's 52. 52 over 31. And then we have negative 4. Negative 1 times 4. And 7 times 12, which is 70, 84, plus 84. So the answer there is 80 over 31. Which seems a little odd, but let's just check the answer, because this is one that's in the book. So this is problem, or did I make this one up? I think I may have made it up. So I'm going to put it on pause, run it through my calculator, see what the answer. Okay, so that is the right answer. So that's the solution. If you plug those in T here, you'll get the right answer. So let's just do that. So you'd have 7 times 52 over 31 minus 3 times 80 over 31.
So 7 times 52 is 364. So you have 364 over 31 minus 3 times 80 is 240. So you get 240 over 31. So 364 minus 240 is 124 over 31, which is 4. And then the second one is x, so that's 52 over 31 plus 4 times 80 over 31, which is 52 plus 320. 4 times 8 is 332, add 0 over 31. So 320 plus 52 is 372 over 31. So do that, divide by 31, you get 12. So there you go. It does work. So that is it for this section. The whole idea here is that if you have a system of linear equations, you can write it as a times x is equal to b. And then if you take the inverse of a, you can take the inverse of a times b, and that gives you the solution.